We'll now continue with section 1.7 and begin to look at some applications of quadratic equations. We begin with the following example. Robert stands on the topmost tier of seats in a baseball stadium and throws a ball out onto the field with a vertical upward velocity of 60 feet per second. The ball is 50 feet above the ground at the moment he releases the ball. When does the ball land? We have a general form for an equation that represents the path of the ball. In this general form of the equation, g, v sub 0, and h sub 0 are all constants. G is the force due to gravity, and it's typically 32 feet per second squared. V sub 0 is the initial velocity. And we're told that the initial velocity is 60 feet per second. The h sub 0 is the initial height. And we know that the ball is 50 feet above the ground at the moment he releases the ball. So what we can do is take our basic information and plug it into this generic form of the formula. So I'm going to plug in my 32 for the G, my 60 for the V sub 0, and the 50 for the initial height. Now the question is asking us, when does the ball land? So the question is asking us to find the t standing for the time. So what are we going to put in for the h? When the ball lands, the h, the height above the ground, is going to be 0. So I am going to set this equation equal to 0, and we'll do a little simplifying as I go. Half of 32 is 16, so I'll have negative 16t squared plus 60t plus 50. And this is the formula that I'm going to work at solving. So this is just a picture of what's happening. We can see that he's at the top of the stairs. He's throwing the ball from that height of 50 feet. And we want to know what happens when it reaches the bottom and the height is 0. We have our formula that we're going to work at solving. Now, because of the numbers in this formula, it's unlikely that we're going to be able to factor it, although you could try. Perhaps the easiest approach is to simplify the calculation by dividing both sides of the equation by -2. And I chose -2 because negative 16, 60, and 50 are all divisible by 2. So I'm going to come in and I'm going to divide each term of this equation by -2. This is not absolutely necessary, but it'll make the calculation easier. So we'll have 0 is equal to, this turns into a positive 8t squared, which positive numbers leading that quadratic equation is always a good thing. 60 divided by -2 would be negative 30t, and 50 divided by -2 would be negative 25. And now if I can't factor it, then I probably would want to use the quadratic formula. So I would have t is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And we'll plug in. Our a value is 8, our b value is negative 30, and our c value is negative 25. So plugging in negative, and then we have the b, so we've got a negative 30, plus or minus the square root of b squared, so negative 30 squared, minus 4 times 8 times negative 25. And then we are dividing that by 2 times 8. So this negative 30 becomes a positive 30. Underneath the square root, negative 30 squared is 900. A negative 4 times 8 times negative 25 would be a positive 800. And 2 times 8 on the bottom would be 16. So we have 30 plus or minus the square root of 1700 over 16. Now, we can definitely come in and simplify this, and it's not even that difficult to simplify because we could write the 1700 as 17 times 100. And then I cannot take the square root of the 17, but I can take the square root of the 100, and that would be 10. And remember, you can simplify as long as you can simplify all three of those terms. So they are all divisible by 2. 2 goes into 16 8 times. 2 goes into 30 15 times. 2 goes into 10 5 times. And so we end up with 15 plus or minus 5 on the square root of 17 over 8. Now you will find that for a problem like this, the answer is most meaningful in decimal form. And so you probably want to go ahead and type that in your calculator, plugging it in one time with a plus and one time with a negative. And so when you do that, for your answers, you're going to get a negative 0.70 and you're going to get a positive 4.45. Now remember that these are times. So to say that the time that it took for the ball to hit the ground was negative 0.70 seconds, that doesn't make sense. So the only logical answer is 4.45 seconds.